This section becomes a turning point in our proofs. We have worked on proving triangles congruent because that is one of the most common things to do. But this section now puts in this phrase that you will come to know very well. Corresponding parts of congruent triangles are congruent. I actually introduced this phrase when I went over congruent polygons in section 4.1. This phrase will get used as a reason in a proof a lot. Fortunately, there is a common abbreviation for it, Cpctc. Don't forget what all the letters stand for, but that's what you can use as a reason in a proof. People like saying it out loud for some reason, Cpctc. Probably because it all rhymes. Every other letter is C. I don't know, but every year many students like saying it out loud. Cpctc is so useful because if you know triangles are congruent, you know 6 congruencies. That's a lot of useful info that can be used. Cpctc is there to tap into all of those things so that you can use one or more of those pieces to finish your goal. And I can't stress this next point enough. This is by far one of the most common things to do in proofs. You prove a pair of triangles congruent, then immediately. And when I say immediately, I mean it is almost always the very next step. You use Cpctc to use one of the 6 congruencies to finish your proof. This will make more sense when you see an example. Here is a picture with 2 obvious, what look to be very possibly congruent triangles. More often than not, if you see 2 triangles that look congruent, your goal will be to prove those triangles congruent, and somehow Cpctc will be useful. So let's start where we always start, with the given. Free points are always a good thing. This step should be automatic. But now let's see what the given is actually telling us. The first part says we have perpendicular lines. With perpendicular lines, we have right angles, specifically these ones. But I do actually need to say that in my proof. And the perpendicular symbol is really short for the word perpendicular. And any English word showing up in a proof probably means we're going to use the definition of that word. In this case, the definition of perpendicular. That's what we have to do next. I can say that angle ADB and angle CDB are right angles. Why can I say that? Where did that come from? It came from our perpendicular lines. Step 2 is put more English words in our proof. The next step when you see English words is almost always to translate that into something more useful, using the definition of whatever the English words are. That's what we will do now. If I want to prove the triangles congruent, I'll need to show that those angles are equal. And since they are both right angles, we know that both angles measure 90 degrees, due to the definition of right angles. But all that work we did is really just the first part of the given. 3 steps for just the first part of the given. What about the second part of the given? Fortunately, that's a lot easier. It's just showing 2 angles are congruent. So I'll plop that information into my picture by marking these angles congruent. Now that we have dealt with a given, let's see where we stand and how we will get to our goal. We eventually need to show that line BD bisects line segment AC. How do we show that? We need to show that these 2 segments are congruent. Let's work backwards from there. How will we get those segments congruent? Let's prove the triangle's congruent, and then use Cpctc since those segments I highlighted are corresponding parts of those triangles. So now the trick is we need to show the triangles are congruent. Right now we have 2 matching pairs of angles from our given, but they have a common side. So let's add that in. We now have an ASA pattern for both triangles. That's enough to have our triangles congruent. The very next step after proving triangles congruent is almost always Cpctc. So let's do that to show the segments we need are congruent. I can't stress enough that those almost always come together. Prove triangles congruent, then use Cpctc to get one piece of it. Now we can get to our final step. Once again, English words are involved, so the definition of those English words is sure to be around. So now we are done. And there's your example of how we will be using Cpctc a lot in the proofs throughout the rest of this course.